Good morning or good afternoon, learners. So this is the introduction for the Heating Earth Surface Lab. So let's begin by thinking, where does all of our planet's heat come from? That's correct. In fact, all of the light and heat that is naturally made in our entire solar system comes from the sun. So I want you to think about walking barefoot on a hot summer's day. Are there some of these materials in the picture that you would avoid? Are there some of these that you would jump to if you had the chance instead of walking on one of the other ones? So think about sidewalk pavement, grass, sand at the beach, or wood. So on a bright, hot summer day, if you had to walk barefoot down a dark sidewalk or down pavement lined with green grass, which surface do you think would be most comfortable to your feet? You're probably saying the pavement lined with green grass, and you're correct. But why? Why does that happen? Because after all of the energy is still coming from the sun. So let's take a look at this picture. So we have an air temperature of 54 degrees Fahrenheit. Notice that the sunlit asphalt is 66 degrees Fahrenheit. That's the hottest temperature. We have sunlit concrete at 59 degrees Fahrenheit, while the shaded concrete is 13 degrees colder at 46 degrees. The sunlit grass is 56 degrees, but the shaded grass is 40 degrees. So then, if all of this energy is coming from the same place, our sun, why isn't everything heated up to the same temperature? That's what you're going to be exploring today. So your key question for the Heating Earth Surface Lab is, how do the heating and cooling rates of sand, soil, and water compare? I want you to make a prediction on your lab sheet. I want you to think about which of these materials, sand, soil, or water, will heat up the fastest. And I also want you to think about which of them might cool down the fastest or cool down the slowest. So record your prediction, pause me, and then return. All right, welcome back. So now that you've recorded your prediction, let's go over your lab setup. So for my on-campus learners, you will actually be doing this lab and collecting data. For my digital learners who are not on campus, this data was collected last year for you in the classroom. So this is real classroom data that you will be analyzing. So notice that we have three materials. We have water, we have light colored sand, and then we have soil. And we are going to use the lamp to represent the sun. And for 30 minutes, you are going to collect temperature data from all three thermometers every 60 seconds. So you'll definitely want to do this in groups of 2 or 3. The first 15 minutes, you will have the lamp on to represent daytime, and you are looking to see how these materials heat up. Then you'll turn the lamp off, and that next 15 minutes will represent nighttime, and you'll be looking to see how these materials cool down. Once you have collected your data, or if you're on digital campus, are ready to analyze it, you will be creating a triple line graph. So just a couple of gentle reminders about graphs. So remember that we use line graphs to show change over time. And in this case, we have change in temperature over time in minutes. So you will need to include a graph title. Your x-axis should be time, but you won't be in years here, you will be in minutes. Your y-axis is going to be in degrees Celsius. And I also recognize that you may not need to start your graph with 0 at the origin, because at a minimum, you're going to be at room temperature. Please try to choose an interval for your graph that shows those small changes that you may have noticed. And then last but not least, please be sure that you include a key. So your water should be one line, your sand should be one colored line, and your soil should be a third colored line. So please use different colors for each one of them and include that information for me in the key. Then, once you're finished, complete your analysis questions. Have fun!